and this is my engineering design process for the Bristle Bot. So the ask was, how does the Bristle Bot work? Well, it works using a closed circuit, the motor and the battery. One of the wires has to touch the battery, and then the other wire has to touch the battery, and it creates a closed circuit, and that's what makes it vibrate and move. One of the Bristle Bot's essential parts, the battery, the motor, and then a lightweight body. The motor obviously isn't huge, and so if the Bristle Bot was any bigger or heavier, it probably would not work. So for the imagine part of this, we were supposed to imagine what modifications we could make to the Bristle Bot and what materials do we have that we can use in our redesign. I struggled with this for a while. I thought, and I wasn't even sure I understood what I was supposed to do. The first thing that came to my mind was, oh, well, I'll just take the motor and the battery and I'll stick it on a toy car and it'll make the car go. And then I was like, I don't know that that's really modifications to the Bristle Bot. That's just kind of repurposing the motor and the battery. So then I thought about adding wheels. But with how small the Bristle Bot was, I struggled to figure out how to make that work. So I was looking at the motor and I was like, oh my gosh, it moves like a circle. It looks like a propeller. So maybe somehow I can make a propeller, which then kind of parlayed into, oh, I could turn it into an airplane. So that's kind of the route I went with. So again, I started with the wheels idea, then I moved to the propeller idea. For my materials, I used toothpicks, a hot glue gun, straws, and cardboard. And this took me a while. I had to plan out a couple of days worth of several hours to figure out how to make this work. So here's my original Bristle Bot, just so you can kind of see how it moves. It doesn't really have a rhyme or reason for the way it moves. It just kind of goes all over the place. There's no rhyme or reason for the way that it moves. So this is what I came up with. My fiance helped me. So I used the motor, the end of the motor as the propeller. That's what I started with. So I moved my motor down farther. I unstuck it and moved it down farther. And I left the battery where it was. And this allowed the propeller to move freely. Without hitting the bristles on the bottom. And then we added the cardboard for the wing, and then we added the little cardboard on the back for the tail. And then we realized that the pipe cleaners were really important because they helped balance the Bristle Bot out so it didn't fall over. So then we were like, oh my gosh, we could turn it into a seaplane. So we made not legs, I don't know what they're called, but skis, I guess, almost, to balance it out so that it wouldn't fall over, kind of to replace the pipe cleaners. So here is a video of it going. And as you can see, it definitely moves in a straighter line than the normal Bristle Bot. There we go. So ways to improve. In hindsight, I could have made the propeller a little bit bigger. But I had done that first, and then after we had added the skis, it actually lifted the Bristle Bot off the ground, which kind of turned the bristles into a cabin area for the plane. So in hindsight, I could have made the propeller larger. I would have been curious to see what that would have done for the Bristle Bot. And then I think I would have used cardboard as the skis as well instead of the toothpicks. It was just a little hard to glue onto the toothpicks. We glued two together to try and make it a little bit thicker. So those were two areas where I would improve. Connections among STEM. So this is the original. Obviously, it didn't cover much. Develop and use models and learn how to use new technologies as they become available. And then for the redesign process, obviously it covered a lot more. Move my picture. Ask questions, develop and use models, design solutions, learn how to use technologies as they become available, recognize the role that technology plays in the advancement of science and engineering, and use appropriate tools strategically. And then I'm not going to go over all of these. Obviously, everybody here can read, and I can't figure out where to put my box so that it doesn't block my words. But for the most part, the original, I said no for almost every single category. I said somewhat when it asked if the role of technology in the lesson was clear to the students. Somewhat, and then I said that the lesson does lead to the design and development of a model or a prototype, because it did. And then obviously for the redesign process, there was many more yeses, a few somewhats here and there. And I said no for it engaging in purposeful teamwork. But if you were doing this in a classroom, I think you could easily encourage and turn it into a teamwork project.